Okay, zero and negative exponents. We actually talked about it a little bit yesterday. Anything to the power of zero, what does that equal? 1. Yeah, way to go. That's 1 mark on the test. B. What if I have negative exponent? What does a negative exponent mean? Okay, yeah.
Is it gonna be 1/4?
Excellent. So whenever you see a negative exponent, you flip the base. What is my base number right here? 4. And if you flip it, what does it become? 1/4. Yeah, it doesn't become negative. That's a very good point. This negative have nothing to do with your base being positive or negative. So all it means is you're going to flip the base number. So instead of 4, it's now 1/4. And since you dealt with that negative, the exponent is just the number left. Okay, so you drop that negative as soon as you flip that base. Otherwise, you just flip the base for no reason. Okay, and what is 1/4 to the exponent 1? What is anything to the exponent 1? Not 1, is itself. Okay, so anything to the exponent 1 is just itself. Okay, so let's try this one. Again, I see a negative exponent. My base right now is -2. So if I flip it, my base become? Okay, so let me go back to this one. So 4, I can write it as 4/1, right? Any whole number, I can write it over 1. Doesn't change anything. So then when I flip it, it becomes 1/4. So here, if I put this over 1 and I flip it, 1/2, right? Now, does it matter where I put that negative? It doesn't matter. You can put it to the numerator, you can put it to the denominator, you can put it to a side. It doesn't matter where you put that negative. I just put it to the denominator to keep the consistency. So I dealt with that negative. So what is my exponent now? Michaela? Yeah, I heard it. What's my exponent now? 3. Yeah, sorry. I heard a whisper over here. I thought it was you. Yeah, +3 because I dropped that negative already. I dealt with that negative by flipping the base. So now my exponent is 3. Okay. So this means 1/2 times 1/2 times 1/2. So in other words, 1 times 1 times 1 is 1. -2 times -2 times -2? -8. Okay, that's my answer. But again, you can write it like this, or you can write it like this, or you can write it like this. So notice here, just one negative, whether it's on the bottom, on the top, or on the side. Right? So all 3 means the same thing. Okay, let's try this one. After we do a couple of these, I think you'll get the hang of it. What's my base right here? My base. My base is the whole thing in the 2/3. So when I flip it, 3/2. And now what's my exponent? 2. So 3 squared. 3 times 3 is? And 2 times 2? And there you go. This one is a little tricky. Okay, what's my base here? 0. And if I flip it? Antonia?
I think it's gonna be 0 because I don't think you can divide the number by 0.
Okay, so if we follow the steps that we've been doing, 0 is the same as 0/1. So So we flip our base, it's going to be 1 over 0, right? To the exponent 2. Okay. Who has a calculator? Okay. On your calculator, do 1 divided by 0 for me. Yeah. And that's right. Can you put one person in 0 groups? No. So that's why instead of writing error, it sounds so unprofessional. We use the word undefined. Doesn't it sound so much more fancy? Instead of saying, what's 0 to the power of 2? Error. But now you say undefined. So much more mathematical. All right, F. What's my base here? Yep. Any? My whole base. So this whole thing. Oh, you didn't get a... Here you go. Here you go. Okay, so what's my whole base number right here? -2 over 3. Because I see this negative exponents, I'm going to flip the base. So what's my new base? Yeah. And my exponent?
4.
Good. Okay. What's 3 to the power of 4? 3 times 3 times 3 times 3. Good. And then what is -2 to the power of 4? Brianna? All right. Is it positive or negative? Positive. That's right. Negative inside the bracket. So -2 times -2 times -2 times -2 gives you positive 16. Okay. How are we doing? Do you think we get it now? All right. We can do 2 more examples. Let's do 2 more examples just to make sure we get it. Okay. A, B, C, D, E, F, G. F. Okay, G. Okay. Let's try G. All right. Mohini, give me a number. 18. Justin, give me a negative number.
-7.
-7. Okay. Okay. I have 18 to the power of -7. What's my base? So when I flip it, and my exponent, yeah. So then it's 1 times 1 times 1 times 1 times 1 times 1, which is just 1. 18 to the power of 7. All right. Jasmine chose 7. There you go. Yes. 6, 1, 2, 2, 2, 0, 0, 3, 2. That's because it was 18 to the power of 7. Okay. G, H. Michaela, give me a fraction.
5 over 6.
Okay. And Jennifer, can you give me a negative number? -3. Good. Okay, so what's my base here?
5 over 6.
So when we flip it,
6 over 5.
and my exponent?
3.
Good. So 6 cubed. 6 cubed. You can do this, or you can do 6 times 6 times 6. So you get 216. And 5 cubed.
125.
125. Yeah, 5 times 5 times 5. 125. Okay. Last one. Diction, give me a fraction. A negative fraction.
-10 over negative 10 over 1,000. Okay.
But you can reduce that. Negative 10 over...
1,000.
But you can reduce that.
33.
33, okay. Okay, and I'm gonna say, okay, what's my base? Okay, what do I do next? Should we flip it?
Yes.
Petrol, why not? Yeah. So just because we did like 10 examples of flipping the base, it only applies to when it's a negative exponent. So if it's a positive exponent right here, do we still flip it? No, we do math as usual. Yeah. So did I try to trick you guys? Yes. Yeah. So I'm sure it wasn't just Mohini, but she was brave enough to to demonstrate for us. Okay. So negative 10 square is, what's negative 10 square? 100. And 33 square? 33 times 33? 1089. Okay. So remember, you only flip the base when it's a negative exponent. If it's positive, we do math how we did for the last 10 years. Okay. I want to A, B, C, D, F, G, H, I, J, K, L. Okay. Just 3 more. Okay, this one. So this is tricky. Okay. I said anything to the power of 0 is?
1.
What's my base right here? Oh, I hear 2 different answers. Who says my base is negative 8? Who says my base is positive 8? My base is positive 8. So only the 8 is raised to the power of 0. So this is 1 right here. And so my answer is negative 1. All right. So I didn't lie. Anything to the power of 0 is still 1, but you have to see where that negative is. If I write it like this then. All right. My base is negative 8. And so negative 8 raised to the power of 0, this gives me 1. Okay. One more. All right. Who says the answer is positive 1? Who says the answer is negative 1? The last time I checked, I had 27 in the class. I saw 5 hands. Let's do that again. Who says the answer is positive 1? Who says it's negative 1? Good. The numbers doubled. So this is 1, and then with a negative, so my answer here is negative 1. Here, I'll add in this extra step. It's like this. And so you get that. Okay. Are we good with positive and, are we good with negative and 0 exponents now?
Yeah.
Okay, good. So let's do 2 quick little word problem. Can somebody read example 2 for us? Sean just like, no. Okay, yeah, Angelie. The lack 42. Oh yeah, sorry. It's a Thursday morning. Okay, yeah, sorry, Angelie. Can you read it again?
Graph 21 is a radioactivity element that decays to 1/2 or to -1 of its original mass after every 5,000 years, determine the remaining mass of 10 grams of graph 21 after 20,500 years.
Okay, thank you. So for these ones, there's actually a formula that we can follow. So we have A equals A naught, and then that. Okay, it looks really weird. But okay, so A represents the amount left, or amount at the end. A naught, you use this symbol in science. You use it a lot. So this represents the original amount. So that's what this O is the original. All right. This right here is like the rate of how fast or how slow it decays. I guess you could put an R here if you want for rate. And then this is the how often it changes. So the time of how often it changes. Okay. Do you need to memorize this formula for the test? Yes. Yes. Although I think I'm nice, but there are certain formulas that I need you guys to memorize. So this is one of them. It's okay. It's only 4 letters. It really is. Okay. So we are trying to find out how much of it is left at the end. So we're trying to solve for A. What was the original amount? 10 grams. So that's my 10. Okay. What's the decay rate? Sorry?
1/2.
Yeah, 1/2 or 2 to the negative 1. So we'll just say, I'll write 2 to the negative 1 right here. It's the same thing. 2 1/2 and 2 to the negative 1 is the same thing. So we write it like this. And how many times did it change? So, sorry, actually, you know what? Let me rephrase that. So how many times it changed? I think that's more. It makes more sense. Easier to understand. Instead of saying how often, I'll just say like how many times it actually changed. So, Petro, what were you gonna say?
5 times.
How did you get 5? I don't see a 5 here anywhere.
It changes every 5,700 years, and 5,700 goes 5 times.
Perfect. So here, you're actually doing 28,500 years divided by 5,700 to figure out how many times it revolved. So in this case, here it's 5 times. So over that 28,500 years, it changed 5 times. Right. So based on what we know, exponent raised to another exponent, what do? Multiplication. So 2 to the power of negative 5. Here, we can do like this. 2 to the power of negative 5. Based on what we learned 10 minutes ago. All right, negative exponent. What do I do to this? Flip the base. So the 10 is still on the outside. I flip the base, so it's now 1/2. My exponent is 5. So 10 times 1 to the power of 5 is 1. 2 to the power of 5 is 32. How do I multiply this? I have a whole number times a fraction. Only multiply the top. Yeah, so 10 times 1 is 10. 10/32. I can reduce this to 5/16. That's my final answer. Will I get full marks?
No.
What am I missing?
The unit.
What is my unit?
Grams.
Perfect. You guys are so good. Okay. Okay, let's try one last one. Who can read example 3 for us? Dikshan, you got nominated.
The KIF28 bacteria triples every 20 minutes. If there are 20 grams of KIF28 at 9 a.m., how many grams of this bacteria is present at 12 a.m.?
Perfect. Thank you. So this thing, these are just like if you're in science, you know, none of the names really mean anything. So this is just a name. Okay. So this bacteria that's on your desk, yeah, it's gonna triple every 20 minutes. So at the beginning of school this morning, there were 20 grams of this bacteria on your desk. So let's see how much there is at lunchtime. So we're gonna use this formula: A equals A 0R to the T. Right? What was the original amount?
20 grams.
20 grams. What is the rate of how it changes? Triple. What number represents triple? 3. Yeah, that's it. Triple. Triple means 3. And what number am I putting for T? Dun, 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 dun. How much? 9. Petro says 9. Do you guys believe him? Yeah, some people believe you. Okay, Petro, can you tell them how did you get 9?
Every 20 minutes it changes, and there are 3 hours, and there's 3 sets of 20 minutes in an hour.
Okay, so from 9 a.m. to 12 p.m., that's 3 hours. So I want to divide it like this because it changes every 20 minutes. But what's wrong with what I wrote right here? The units aren't the same. So how many minutes is in 3 hours? 180. So 180 divided by 20. Now this is minutes, this is minutes. I can divide because it's the same unit. So that means it's 9. So T equals that. Okay. Do I need to flip my base?
No.
Why not? Right, my exponent is not negative. So I just do this math how I did it for the last 10 years. On your calculator, 2 ways. You can either do 20 bracket 3 close bracket exponent 3 like this, exactly how I see it. Or you can do BEDMAS. 3 to the exponent 9 gives you this, and then times 20. Either way, you should get the same answer, which is 393,660 grams. So the desk that you're touching right now has 393,660 grams on it right now. And that is why you should always wash your hands before lunch. All right. Any questions? All good? Okay. On the back. Hi. Oh, yeah. Yeah. So one second. So on the back are some questions. Just do these ones. 2, 3, 5, 6, 8, 11. All right. If you look up here, I bubbled it. I circled it. So just do these ones. If you don't read the instruction carefully, then you're doing a few extra questions, which is fine with me. Okay, so do those. Right here, though, number 5, they called it iodine 123. So the original mass is 123. And same with this one, I think. Yeah, so for these ones, they actually use the number as the gram at the beginning. Okay, so for some of these questions, that the name that they use is actually the amount. Okay. Yeah, so I think it's good. So try these. Answers are right here in the bubble. So do try it out. Tomorrow, beginning of class, we can take up some of these. Sounds good?
Can you clarify for number 4 which was addition and which was
Oh, sorry. Evaluate using pen and check your results using a calculator.
you're not supposed to do before?
Yes. Thank you, Petra and Dikshan, for listening so closely. All right. So my lesson was exactly 25 minutes, Mohini.